Hi, I'm Clark. I'm going to talk about Pandas. So Pandas is a data analysis library. For this talk, I'm going to be using data from Titanic. So here in the data set of Titanic, we have a 1,309 people with 14 columns. We have it's the passenger's class, if he or she survived, the name, the sex, and age, and a lot of other variables. So for querying, we could obtain the male passengers via the syntax, the square brackets, and yeah, we obtained 843 rows out of 1309. We could get the shape of this data set. Of course, we have 853, and since that was a tuple, we could get the first index to get the number of rows. All right. So 843 males, 466 females. The number of survivors are 500, regardless of gender, and we have 809 non-survivors, with a total of 1309. How about the males that did survive? So we have 161 out of 800. The males that did not survive, 600. Females that survived, 339. Females that did not survive, 127. Males sorted according to fair amount. We have the most expensive is 500 British pounds. Nowadays, this is worth around, I don't know, 10,000 British pounds. But back then, this was a lot of money. I'm guessing this person bought at the last date, so that's why it's that much more expensive. Females, uh, this was the spouse of, these two are the spouses of the ones mentioned above. Surprisingly, some people got aboard for 7 British pounds. These are the people that are in the steerage, or the third class. Sorted by age, the most eldest is 80 years old, and the youngest is 2 months old. Uh, Survival boat. I was frustrated because the data from the data set is not very much clean, and I didn't have the time to clean it up. So let's get this one. For fair, the ship obtained a total of 53,000 British pounds. The median being 14 pounds, and mean being 33 British pounds. Um, So again, males 843, females 466. So a ratio around 2:1. For males, the sum of the fair amount is 22,000, while in females around the same number. So that means females have much more expensive tickets than males. Age, not that much different. Um, so they're around at the late 20s. So of course, when we graph it, the graph would show people, much more people are in the late 30s than compared, let's say, to other ages. For fair, we have much more people buying at a lower price, which are considered third class. For the first class, we have people buying it at, I don't know, 30 British pounds. The more expensive ones are 500. And second class, only 70 British pounds compared to the first class with 500. And for third class, we have pretty much the same, except that there are much more cheaper tickets compared to second class. That's all. Thank you.
I am Ellis Iver from Mapua University, 5th year electronics engineering student, and I'm here to share with you our application in Python and OpenCV. Before I start, may I see the hands of those who are familiar with OpenCV? Wait, there's quite a lot. Thank you. And our application is American Sign Language Detection and Recognition using Python, OpenCV, and scikit-learn's decision tree classifier, and I'll add more Python and OpenCV applications. So, we started with finger spelling because finger spelling is a significant part of sign language. This is a technique used in indicating proper nouns, names, places, brands, and other uncommon words. These are the finger spelled letters. And we use 8 features to extract features from the hand. These are, that is the normal hand, and that is what the computer sees, and when you combine both, that is the representation of it. These are the features: convexity defects, ratio of hand contour, convex hull, boundary rectangle, Euclidean distance from extreme points, and with those features, this is the process from real hand, convert to grayscale, Gaussian blur, inverse binary, hand contour, then extracting all features will lead you to this. Those are the values that we obtain from extracting features from our hand, and there are 8 features from letters A to Z. We use those features in our supervised machine learning tree, and a quick concept. So how do you describe those truths? We often use color, size, and shape to describe those truths. It is the same as describing hands, but using these classifiers. So as a demo of our project, here, there. For A, we detect B, and then it displays the equivalent letters. Bakit nag-lag ko yun? We did this for the letters A to Z, and the applications of this are, aside from medical field, we can use this for home automation. Example, there's a camera in our home, and then we sign A. We can represent A as turn off the lights, turn on the lights, or other applications. And so, additional topic about OpenCV is that we can apply OpenCV in the medical field for fracture detection, strabismus detection, or crossed eye. We can also count blood cells using OpenCV and detect tumors using OpenCV. As for automotive and manufacturing, we can use this as to count traffic, vehicle speed detection, and drowsiness detection, wherein when the computer vision detects that your eyes are closed for a while, it can send alert to an alarm that will awaken somehow the driver. And we can also use it in sales and marketing. For example, in every shop there is a CCTV camera. We can program that camera to detect new customers, returning customers, and we can study the customers' behavior preferences, and we can prioritize those customers who are always visiting our shops. We can also detect those thieves and other bad influences in our business. As for the surveillance, we can use it in our home, and in addition to this is in military applications, but I would not recommend military applications because has anyone of you seen although it's not yet implemented, those mini drones that tracks you and then they'll go in your forehead and they'll explode? Did you know those things? But they're not yet implemented. I think in the future, OpenCV can be deadly because some people might use it in military applications, such as using those drones with sniper guns. But I hope, as we are sharing good information only here, and I hope we only advocate those things that will benefit the humanity. As for conclusion, maybe there is a reason why Python's logo is like this. It is a powerful language, and we can both use it in good or better ways, but I hope we as Python programmers in this modern era will use Python for the benefit of our generation. Thank you.
Hi, good afternoon. Mine is a game. Actually, this is my first game created in Python. I created it from scratch. My graphics are all, I just painted it in Paint. And yeah, I decided to create a game because, I've been tired of creating systems like websites and point of sale, whatever it is. So that's why, for a change, I've created a game. Actually, this is just a draft. I've decided to create it with a mix of Mortal Kombat and, Dragon Ball. So, yeah, here it is. Yep, it can do Kamehameha Wave. Yeah. I would like to have an arcade and a PvP. But, yeah, it's not yet finished. And, yeah, it's kind of cute. It can also do, like that. And, yeah, it's very cute. Yeah, that's it. Thank you.
A little about me. I am 9 years old. I study at Don Bosco Technical Institute of Makati. I play table tennis. I like salmon sashimi. And I want to be a game developer someday. This is me and my sister at PyCon PH 2015. This is me during a tournament in table tennis. This is my version of everything done in Scratch. This is me tinkering with the Raspberry Pi and Sunfounder. I'm pressing a button which makes the light turn on and off. Today I will show you Minecraft and PyCraft package on a Raspberry Pi. Let's get some big words out of the way first. Raspberry Pi is a small computer. Minecraft is a sandbox game by Mojang where you can build and create things, structures and stuff using different blocks. PyCraft is a Pythonic Minecraft library that helps me create things on Minecraft easily using Python codes. Jupyter Notebook is where I type and run my codes. Let's start. First, we import the PyCraft package and say hello world. Says here hello world. Next, let's check like coordinates. It says I am at positions x0, y20, and z0. Now let's put some grass. There is what's below me. There's grass below me. Next, let's put a TNT block 5 blocks away from me. We'll just do it here. 1 minute left. Finally, let's make a TNT wall. I am inside the wall. I'll just move out of the wall. That's it. For more info, you may visit pycraft.readthedocs.io. Have fun. Thank you.
So good afternoon. So I'm Mark Reyes. So what I'm going to do now is image painting. So it will what's the expected is instead of using a network to go from some x position to the value of a sine wave, what we're going to do instead is to teach the network to go from a location on an image frame to a particular color. So given any position in an image, the network will need to learn to color to paint. So next is, before we can do that, is that we should know the anatomy of an image. An image tensor has three dimensions: width, height, and color channels. For example, if that's my image, it has a width of 1,500 pixels, height of 1,000 pixels, and a channel having all complete colors, which is the red, green, and blue. So this is what we're going to do to repaint the image. So first is you import the image. Next is collect all image position in our list and the corresponding colors of each position. Loop over the image, convert the lists into a NumPy array, make necessary computations, use regression to predict the value of the pixel given its position, and build the network train and see the network paint. So our input here is the cat. So I already have run this application because it will take a long time to iterate. So that's the cat. So we want the network to paint again, to repaint the cat while iteration. So this is what we did. So what I did. So first collect all the positions in the image in our list. So we need to get the positions of the positions in the image, and then we'll also store to get the responding colors. And now we will loop over the image to know to have it to train to the network. And then we need to normalize. The purpose of normalization is to get only what's the needed information, and then you get the shape. So tip is you need to when you need to enter images into a network is that you have the same dimensions of the width and the height. So I already have resized it. So from a big image, I need to resize it because longer images need longer time to be processed with the network. So this is the resized image. It's now 64 by 64 pixels. So I used TensorFlow. So what I did is to make a placeholder for the x. So the x is the position and the y is the colors. So now I have to build the network. So it's a neural network. So I need to have a neurons, and then to iterate over. Now I have to train. So when training, you need to have a cost function to evaluate whether we're going to the right track. So instead of using gradient descent optimizer, I used Adam. And next is that I now train the network to have it print. So this is the result. So it doesn't look like the same image actually, but the network tries to repaint the image that was trained into the network. And the longer the iteration, the better it will try to repaint the image that is inputted into the network. So that's all. Thank you.
Okay, so the Global Game Jam is a hackathon in which we have 48 hours to create a game. The Game Jam theme for this year was transmission. So, okay, and I made 32 games within the last 48 hours. It's called the theme is transmission, and the game is called 32 Weeks of Delivery. Let's go. Game number 1. Have you tried turning it on and off again? Click. There we go. Game number 2. Mask button to minimize latency. Number 3. transmission. Where's the dog? Hello. Then transmit the cuteness. Yeah, more cuteness. Enter the two authentication factor. Up, down, left, right. Go ahead, the male and female. Connect. Doesn't work. We flip. Doesn't work. How do we flip this? We do it 3 times and it works. Right, feel right. We do it. Now, if too many people are using the Wi-Fi, we use put to get rid of them. I don't know how that works. This is video game logic. Oh, this thing is harder than I thought. There we go. Upgrade your computer to minimize lag. Let's go to Cyberdyne, Gundam XD, and Eidetic Memory. Dance quickly to the speed. There we go. Select the correct card using your psychic powers. Right. What's everyone's thinking? Number 3. Doggy, yes. Fix the TV or you miss the show. Bang, 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 bang. Tune the TV to watch your favorite show. Okay. To receive a Wi-Fi pass when you go to coffee shops, you buy stuff. Water bottle, cappuccino, who cares? We need Wi-Fi. Share your regrets on social media. Transmit your message to your crush. One press. Transmit the love letter. It's a maze in which you need to let those two together. Hey, I made this game. I should be able to cheat. That's about what I say. It's a cheat. Jump! We all play this game. If there's no transmission from Wi-Fi, we jump. Oh, I missed. There we go. Clap to transmit a bit of noise. This part of the game is very buggy, so I put in a cheat code. Sell trash to boost Wi-Fi. We don't need UFO parts, full bars, scanner, dirty, aluminum sheet, at the vacuum. Who needs that? See, Statue of Liberty. We need Wi-Fi. Find the strongest signal and sell. So try to find the one with the largest signal, and there we go. Help Mr. Jimmy must find the signal. Over here. Transmit your light. You guys like my game, right? Yeah! Safe and energized. There we go. Crowd surfing is hard. Okay, there's supposed to be a door over there. Okay, transmit your knowledge to your brain. Your brain, your knowledge. Transmit toothpaste. Transmit toothpaste to teeth. Hey, it's hard to think of 32 genes for transmission. Charge to the end, denoted in thought. This is how a Jenko drummer does. Repeat the same sprite over and over again, regardless if it made sense or not. Also, I was running out of time. Prevent the package from the space invaders. See? Reuse your code, reuse your art. Transmit by pressing all the buttons. There we go. And this is the last game. It's so obvious I ran out of time because you're supposed to transmit Wi-Fi to the next car. The next car is over here. And then I'm Mr. Valdez, and as from our planet, as I say, green roads we need the sick.
Okay, so this is the continuous delivery and continuous migration for the e-commerce project using GitLab. So that means we're going to do automated testing and automated deployment. So here we go. To accomplish that, here's the things what you need. You need to set up the GitLab for the integration. You need the Docker image, OpenShift as a target, and the Ansible for the manual deployment to the let's say other cloud providers. In your backend, you need the automation test tool. It is a Python, Tox, Plates, ICE, or PyTest. In your backend, it's in, like for example, Django, Redis, Celery, Solar, Postgres. In front end, you need this stuff for the automation test tool, ESLint, Chai, Mocha, Selenium, and whatsoever in there. You need to also, in a front end, Node.js web environment, Angular less, and ES6. So when the developer push the code, this will going to happen. The pipeline stages, these stages are the image, QA stage, install stage, build stage, test, and deploy. So I'm going to interject here that when you're doing the deployment, we are not going to do the git pull directly from the repository and put it in the deploy. It should be from the build, and that build acts or provide an artifacts, and after it has been tested, then you will go into deploy that kind of artifacts. So this is the GitLab pipeline in action. I'm showing you the pipelines list. So as you can see on the top, this is the past pipelines. So it is in orange. The orange one means there is some warnings. Here on the second screenshot, which shows the jobs list, you can see here that there's a QA colon versions. That means there's some outdated libraries in use, but it is a warning, so it's fine to continue. QA JavaScript, right there on the top, this means there's some problem on ESLint, so it doesn't continue. So as you can see, it is just finished on the second pipeline. On the first pipeline, as you can see on the top, again, so it finished all the the first stage is build, install dependencies, build, test, and deploy. So that's why it's just passed. So next is this. We're going to take a look inside each, or not each, one of the items inside the job list. So as you can see, this is the pipelines. Inside the pipelines, there's the jobs. Here's the jobs. Like for example, I'm going to the images where we have the Docker here. And the QA stage, we have a lot of linter, isort, Plague 8, JavaScript, ESLint. In install, we have the install.js dependencies and the install talks for the dependencies and Pythons. After the installation has been done, there's a build here. So after the build, there's a test, a lot of tests, including end-to-end test staging. There's a staging going under, and the deploy stage. So I'm going to discuss here the test specific on parallel jobs, how it runs. So here, when the developer push into the GitLab, we have a lot of GitLab runner here, and the GitLab will go into kick a job into the pipelines, and the pipelines will go into start a job. So this will going to happen on the, like for example here in test. So these are the parallel tests running on here. So next is inside the jobs. We're going to take a look inside the jobs. This is views inside it. So this is a single container. Like for example, you have here multiple jobs running. So you can see a lot of here in the GitLab integration. This is the running of end-to-end testing using the Selenium with a Mac server. So as you can see, it will going to download some artifacts from the build, and it will going to test it. This is the views of the test when you run the end-to-end testing. So it starts the Selenium in there, and then this is just one of the tests here. So as you can see, there's a tested suite, like a support information and project list. So yeah, this is one of the tested suite. So by the way, I'm Junji.
Good afternoon. So I'm just going to introduce to you a type of game that I love playing. Is a roguelike game. Anyone have heard of roguelike games or played roguelike games before? Awesome. So usually roguelike games are you can think of them as dungeon crawling games with levels that are generated procedurally, and then it's usually the theme of games are usually around high fantasy like Lord of the Rings, Dungeons and Dragons, and then one prominent feature of the game is that your players die permanently. So it's a hard game, turn-based, action, hack and slash game, but it's good. I just want to share. So these are some of the what the games look like. So usually they use ASCII characters, but some have graphics too. Yeah. Okay. So you can look it up, roguelike, and then I'm just going to present to you a library in Python that you can use to write your own roguelike games. So the library is called TDL for TDL. Just you can install TDL, and then you can follow a tutorial in rogueliketutorials.com. And then I'm just going to show you something that I did that is built around this tutorial. So my source is in github.com, creative codesmith, rogue dungeon. And then I have a sub branch called version 2, which is actually the one that is working. And I'll just quickly show you what it looks like. So this is the game. I press A. So you can see my character is a @ I can grab this potion here. There's a sword, which I can grab too. And then there is an orc that's represented by the O. Then I just have to kill. If you notice, my life points are shrinking, but now I've killed the orc. And then I can go down the level here. So another orc comes in. So I just keep on, yeah, so this is what the game looks like. And then essentially you can play around with this one, have your own rules and your own monsters and enemies. And yeah, so that's it.
I am Sandrea. I am from Davao. I am a full-time Python programmer, and it's my third time attending PyCon. I am very fortunate enough to be able to attend PyCon and be able to integrate or use my learnings in my job, in my personal projects, and even my startup. So I have here a simple startup. I started it December 2016. It is a retail store that sells humors online. Just the two of us with my sister. Sometimes I do the inventory, and then she does the operations like what you call it, shipping and Facebook inquiries. I noticed that as our business grow, it is becoming increasingly difficult for us to reply to inquiries like how to order or where is your physical store and a lot more. And every day we just send back inquiries, and that's very tiring. So fortunately, last year there was this talk about messenger bot. So with my interest, I created. This is the website, and then for one thing, that is where since it's WordPress, so good thing WooCommerce has its own API to set it up. I set up also my Facebook developer messenger account, and then that is for sending just plain text. So mapping common questions from customers, and then that is for my first employee, just to send message from. So I have here my Facebook page, and that's by our messenger. So this is the admin for the and I asked my colleagues to try it. If you want to try it, you can message me on Facebook. So for instance, we have here Yeah. Yeah. So here my colleague asked, we have different types of, these are our different products. For instance, Audrey, Mercury, and Sensablock. Yeah. For instance, somebody would ask, is they available? That is the bug. Yeah, so is they available right away? It would return our available stocks, and then the price, and then size chart. Because most customers really want to know that, and then when we click, it would redirect us to our account. So let's try again. So God, would you mind, or whoever would want to chat, just how to order or your yeah. So let's try. So yeah.